Once again, good morning. Our lesson today is about the normal distribution, and this will be all for chapter 2. Now, our memory verse is found in Genesis 50, verse 3. It says, It took 40 days to complete the process, the normal period required for embalming. Meanwhile, the Egyptian mourned for him for 70 days. This is a very short lesson, and at the end of this lesson, you will be able to illustrate a random variable and its characteristics, and also construct a normal curve. Now, your venture with me is about the cornfield. Now, what's about the cornfield? Normally, in a cornfield, we see few tall ones, few short ones, and most of them having heights between tall and short. This is one of the applications of normal curve. What I mean to say is normally, that's really normally, when you see a cornfield, you just don't see uniform ones, like all tall, all short. There's always the tall, the short, and the average ones. Or for example, if you take an exam in stat and prob, they say it's normal that few will get high scores, few will get low scores, and majority are in the average. Or you might ask me, ma'am, is it possible that in a board examination, everyone passes? I should say no, because normally, that's what we call normal distribution. Normally, there are few top notchers. There are also people who fail and people who score within the average. That is a normal distribution. You don't expect all will be on top, all will fail, but normally that is how we distribute the data. Now, our lesson today is about the normal probability distribution. There are many distributions, and this is only one of the many distributions that you will have. What is this about? In the normal probability distribution, you see at the bottom, we have -3, -2, -1, 0, 1, 2, and 3. In the zero line, we will see the mean, the average score. It's also the middle score, the median, and the mode. The mode is the most occurring score. That's why the tip is the tip of the curve is at 0. So let's discuss some properties of this curve. Number 1, the normal curve is in a bell shaped. Later, you will realize that it could be skewed. Like there are more upwards, there are more downwards. Second, the normal curve is symmetrical. It means the left and the right sides are equal based on the center, 0. Next, number 3, the mean, the median, and the mode are at the center or at as z-score 0. Number 4, the width of a curve, or is it flat or is it clustered? It would depend on the standard deviation. You need to remember this word, standard deviation. It determines the spread of your curve. Next, number 5, the tails are asymptotic. Remember, remember what asymptotes are? It goes nearer and nearer to the axis, but it will never pass the axis. And number 6, the area under the normal curve is 1. Or if we add all the area under the normal curve, the total is 100%. Now let me describe the standard normal curve. What's a standard normal curve? A standard normal curve is a normal probability distribution, and the mean is, or the mu is 0 in the middle, and the standard deviation or the gap is 1. Example, it's 1, 2, 3. The gap is 1. Or -1, -2, -3. The gap is 1. There are 7 standard deviation units in the baseline of the normal curve. And the normal curve starts from -3 up to +3. Now, we'll determine areas under the normal curve. And how do we do it? I just uploaded a while ago, I guess 5 minutes ago, Appendix A. You can go to your Z table and let me show you how to read the Z table. Let me go to the Z table in the next one. Here, this is what we call the Z table. There are 2 kinds. It can be the alternate version, or the other is the cumulative version. For this class, we will use the alternate version. And you really need to keep a copy of the Z table if you can print it better, because every now and then we will be using our Z table. How to read the Z table? It's very easy. Here, you look at the first whole number and the 10th place, the first decimal. This is in your vertical, vertical. That's what I mean. The last decimal will be in the horizontal. You look at the meeting number, that will be the area of the normal curve. Example, we'll be looking for, where's that thing? Oops, wait. Let's go back. Oh, here. For example, we'll be looking for the area or the value of 1.87. You look 1.8 in the vertical line, and then the 7, you look at on the top. You look at their intersection. The value for Z equals 1.87 is 0.4693. Again, these are all decimals because the sum is 1. Let's go to the next one. Z equals 1. You could have that as 1.00, right? So let's look for 1.0 here and 0 on top. The intersection, the answer is 0.3413. What if it's a negative number? If it's a negative number, negative 2.58, it's the same as positive 2.58 because area is a scalar quantity. So it means it's always positive. So you have 2.5 here and 0.08 on top. The answer is 0.4951. That's very easy. That's how you'll do it. Let's have one more. Ready? Let's look for 2.52. So you look for 2.5. It's here. Actually, I just count it from here. 0, 1, 2. The answer for 2.52 is 0.4951. Another, negative 0.55. It's the same as positive 0.55. So you have 0.5 and then 0.55 on top. Let's have the intersection. The answer is 0.2088. Basically, it's just reading the table. If you notice, the last value will be 3.69. And there is a note at the bottom. For values greater or equal to 3.70, the answer is always 0.4999.